Welcome to our series of recordings giving you a bit of a picture of business and economic statistics. There are 16 videos in total. They, in one sense, follow on from 1 to 16, and so the best way to get the best value out of these is to watch all of them from the beginning, but you can watch a selection of them if you just learn about a particular topic, and hopefully mostly it makes sense. My name is Brett, and I will be giving you the very first of these lectures, which is a very simple one, just giving us a bit of an introduction to what business and economic statistics is all about, the why of what we do, and a little bit of the how. Excuse me. So, first of all, what is business and economic statistics? So the key ideas here is around the idea of economics and business. So we're talking about statistics or data as it relates to the economics and business world. So most of you are probably studying a commerce degree or a business degree, and you're interested in jobs and careers in the business world, and what you're going to do quite quickly is encounter data in those environments, and you need to know something about where the data's come from and how you analyse it and what conclusions you can draw from it. So here's a few examples just on this screen here of a company that's trying to launch a new type of mobile phone product, and they want to know whether or not that product is going to be effective in the market. Will it be popular amongst the target audience? So you need to know something about the people, you need to know something about the kind of products that they're interested in, and then a little bit about the characteristics of your product and so on. Or you might be a bank trying to work out whether to give a loan to a customer, and you want to know something about the risk profile of that customer. You can learn all about the characteristics of the customer, and based on past history, you can learn about, given these characteristics, what's the chances of this customer defaulting on their loan, or house prices going down, or whatever it might be. And then the third example we've got here is just of a company that's setting up a new production plant in a country somewhere, and they want to know what scale of plant to build, what volume of production they're going to need in the future. To do that, they're going to have to predict demand in the future for their product. So it's a pretty tough exercise. It's a very important one. It requires data from the past and then some confidence to be able to predict into the future. So that's just some examples of what we mean by business decisions. And similarly, in the economics world, when we think about economics, lots of areas of economics and markets and so on, but I've got a couple here which just relate to economic policy. So suppose your first job as a graduate is working in the government. You might be working in the social services sector, and you're interested in trying to provide the best possible services to young people who've been cared for by the state in foster care or something similar, and you want to know about how to transition them into adulthood. So you might do some research into the lives of young people after they turn 18 and no longer classify as children. What are their needs? How do they go with employment and healthcare and so on? And what kind of costs does that impose on the state, which would justify some extra spending? Perhaps you're in macroeconomic policy and you're thinking about what the impact would be of reducing taxes. What would that do to supply of labour, to work that people do, or to the income that they have and the consumption patterns they would have? Would it be a big impact, a small impact? We don't know. So those are things that are pretty important, because decisions like this are being made all the time, and yet without data and without analysis of that data, it's pretty hard for us to make informed decisions. So it's all about making decisions, and it's all about making decisions based on evidence, not just based on opinion. In many times, businesses go on intuition or what's commonly accepted wisdom, and often this doesn't work very well. The failure rate for small businesses in Australia, for example, is close to 75% over the period of a few years. So most small businesses fail, and a lot of the reasons for that would be due to the lack of rigorous data collection and analysis. So we reckon it's pretty important. So what you're going to do if you follow your way through all these videos and learn some of the associated material is first learn about what's actually going on. What is the current situation in the particular problem that we're interested in, the set of data that we're looking at. So just even simply summarising and presenting data in a meaningful way gives people surprising insight that people think they know what's happening in their market or with their staff team or with their neighbourhood or whatever it might be, but actually the reality can be quite different. And so learning to know what's actually going on and then learning how to translate that current situation into some kind of information that helps you make decisions is the next step. So it's all very well to know this is what's happening in our neighbourhood or in our community, but then there's another step to knowing what should we do, what kind of services should we put in place to improve the quality of people's lives, for example. And then the third thing you might need to, the skill that you'll have here is actually kind of really about criticising or critiquing those two things up there. What are some of the traps, some of the mistakes people make, some of the things that aren't quite so obvious in the way in which you use data and make decisions from it. So we want you to learn a little bit of critical thinking as you learn about this kind of stuff. A bit of a sales pitch. Data is everything these days. You might have heard this phrase, big data and data analysts and so on. It is a huge growth area. Just to give you some idea, this is what's happening in Google in terms of search engines. This is one way you get an idea about what's popular. And you'll see that terms like economist are going down in popularity, but ideas of things like big data and big data are going up enormously in the last few years, and that's because of the existence of big data and the opportunities that that creates for people to do things that you could never imagine being done in the past. And you think about most data is now captured, most activities of businesses and government are captured electronically, and because they're captured electronically, the data is actually there for people to analyse. So the growth in data is pretty huge, and it's got no sign of slowing down. And the big challenge is that with such a vast amount of data, how on earth do we make sense of it? And that's the job that a data analyst has, with some of the tools that we'll talk about in this unit. Now, analysis has a few stages in it. The first is what we call descriptive, just describing what's going on. The next stage you might describe as diagnostic, where you're looking a little bit more closely at patterns or correlations in data. So you're trying to figure out not just this is what is, but what do you think might be causing things? And one way you identify the cause of some outcome is by saying, hey, look, there's a pattern here. Whenever this happens after it, etc. Now, predictive analytics turns that kind of diagnosis, which is a bit exploratory, into models that allow us to predict what might happen. If you put more money into advertising your business, this is how much extra sales you can expect to have, for example. And prescriptive analytics takes those models and designs helps you make decisions. So designs actions that influence outcomes. So that's just a bit of jargon for you that will pop up periodically through the rest of the videos that you'll be watching. We need to think just a little bit about the types of data that you'll actually encounter when you do data analysis. And this is just a very brief glimpse of it. You'll get more specific examples of this as we go along. But essentially, we're talking about data in a few different ways. So first of all, you've got this classification here between what we call numerical data and categorical data. So numerical data is essentially data that is numbers, like how old are you, what's your income. Those are data that's measured with a number. Categorical data is data that's mentioned in a category. So you maybe don't normally think about it as a data point, but it's information, so it's data. So for example, what country were you born in? Are you what is your sex, male or female, etc.? What is the day of the week, Monday through to Sunday? So they're not numbers, but they are categories, qualitative data. So we might often want things like, in our data set that we've got here, looking at students enrolled in a particular course, we might want to have a little table that we put together of all the countries of birth of the students and see what are the most common countries that people come from, etc. Back to the first category of numerical or quantitative data, we actually classify this in two different subcategories. One is discrete and one is continuous. So discrete numerical data is data that's a count of something or other. It's how many people in your household, how many times have you been to the doctor in the last year, etc. So it's best described as a count. Excuse my bad writing. Continuous data is often thought about it as a measure of something. So how long does it take you to get to work each day is a measure of length of time it takes you. Your height is another measure, a measure of the prices of goods and services in the economy, etc. And the distinction here is a count can, of course, because it's a count, takes the values 1, 2, 3, 4, 5, etc. Continuous can take an infinite number of values because you can measure more and more accurately. So your height can be 1.65 metres, or 1 metre 65 centimetres, and if you want to measure even more accurately, it could be 1 metre 65.3 centimetres. So you can have an infinite number of measures, values of the measure. So when you actually describe continuous data, you might actually describe it in ranges. So rather than sort of, okay, how many people are 1.653 metres tall? That's a bit annoying. You might just say how many people are between 1.65 and 1.7 metres tall, or 1.65 and 1.66 metres tall. So you describe and analyse continuous data a little bit differently to discrete data. So it's important for us to have that distinction and to bear that in mind when we come and actually look at some of the tools that we'll encounter a bit later on. Another thing that we often want to do, excuse me, I'll just have a small coffee break here, is to think about whether the data that we've been given is useful in the form that we were given it. And there's a couple of examples we'll look at over the next couple of slides of this. So you've been given some data, for example, in this case, on the total CO2 emissions. CO2 is bad for the environment, as global climate change, etc., is very focused on CO2 emissions. It's a few years old, this data, but it gives us some idea about which countries are the worst polluters in the world. And this data tells you a story on the left-hand side here of some pretty big problems. In particular, the biggest polluter in the world in terms of kilotons of CO2 emissions is China, 10 million kilotons. So that's a lot of CO2 emissions. And we've got the United States as the second biggest, and India is the third. And if we keep going down, we might see a few others that perhaps some of you recognise. Some of you might be from Indonesia, for example. Indonesia has more carbon CO2 emissions than Australia at 377,000, and so on. Okay, so that's one way of describing this information. It's interesting, and we can say, there you go, naughty, naughty China, you need to do something about it. You're obviously emitting far too much CO2. And Australia, well done, you're not doing too bad. You're down there in the 15th place or whatever it is in the world. Indonesia, you're worse than Australia. That's what you might conclude if you just look at the left-hand column, this set of numbers here. But of course, that would be quite an unhelpful conclusion. Why? The reason is that these countries all have different populations. As you know, China has well over 1 billion people, whereas the United States has less than 300 million. So China's got about 3 or 4 times the population of the United States. Indonesia has about 10 times the population of Australia. So whilst it's true that, for example, Indonesia has more pollution than Australia in terms of CO2 emissions, it has 10 times as many people that it has to support. And so a fairer comparison would be to look at CO2 emissions per person, per capita, in tonnes. Then we can see which are the countries which are polluting the most on a per person basis. So this is the idea of normalising or standardising our data so that we can get a fairer comparison between, in this case, between countries which are qualitatively different. When you do that, you get a completely different story. You'll notice here that in this list, China doesn't even rate a mention in the top 20, because of course, whilst it's got very big emissions, it's got big population. So on a per person basis, their emissions are actually quite low. We see Australia here is jumping up the list, and the United States is fairly similar to Australia. They're not at the top of the list, but they're not great performers. And Indonesia likewise is off the page here further down the list. So we get a completely different story here about who are the big pollutants, and the big polluters are Qatar and Trinidad and Tobago, and another country, Curacao, which I confess I've never heard of. Maybe someone can enlighten me about where that is. But a number of countries, it seems, in the sort of Middle East, for example, there, which is interesting in itself, isn't it? And some of these larger developing countries like China and Indonesia, Mexico and Brazil are nowhere to be seen because they're very high population countries, and so on a per capita basis they're actually not too bad. So you go from a completely different story on this side to that side. On the left-hand side, you say, China, you're responsible for most of the CO2 emissions in the world and you've got to do something about it. On this side, you say, China, you're not one of the worst pollutants. So it really matters how you organise and present this data, and this is an example of the importance of normalising so that you can make a fair comparison. So the principle here is compare like with like. Compare the CO2 emissions of countries having adjusted for the size of the country or the number of people that live in that country. Here's another example of the same thing. This is to do with the fact that comparing over time is not always going to give you a fair comparison. So in this example, we've got some information about gross domestic product, or GDP. GDP is the total income of the country, and you'll see here that we've already done some normalisation or standardisation, because we're presenting here a table of GDP per person or per capita. So we're saying just because total income of the country goes up over a period of 20 or 30 years doesn't mean people are richer, because whilst it's been going up, so has the population been going up. So what we actually need to do is look at GDP per person. And when we do that, look at the blue line, we see that that has been going up as well. So that's good news. So your GDP per person back in 1990 was around about $24,000. And by 2016, it was about $70,000. So that seems to paint a pretty good picture. That tells us that production per person is, nearly 3 times as big in 2016 compared to 1990. So that sounds pretty good. Income per person is substantially bigger. We're a lot richer than we were then. Okay, so we've kind of dealt with one of the potential sources of, one of the potential issues with comparing across time, which is that populations change, and hence we need to do per capita. But what that blue line doesn't capture is another major problem with comparing across time, which is the idea of inflation. In other words, back in 1990, the prices of all the goods and services that you and I consume was much lower than what the prices are now. And so whilst it's true we've got 2 or nearly 3 times as much income in 2016 compared to 1990, prices are also a lot higher. So what we want to do is adjust for that, standardise or normalise for that price effect, so that we get some idea about what your real GDP is per capita. What is the growth, the income, the average income per person, having adjusted for the effects of inflation? So the way we do that is this formula here. We have something called an implicit price deflator, which is less like a price index. The most common price index is the consumer price index, which we'll look at in just a tick. And we divide the GDP per capita by the price index, or the implicit price deflator, standardise it by 100, which you don't need to worry about for now, and you get the real GDP per capita, which is the orange line here. And you'll see it tells a very different story. This says once you've adjusted for inflation, most of that growth that you saw in GDP in the blue line is due to price rises, and that GDP or income per person, were prices to have remained the same, is actually increased only a fairly modest amount, from about that 24,000 to around about 30, looks like about 38,000. So it's gone up a bit. It's gone up by about 50%, but certainly not doubled or tripled like it looked like in the previous graph. So this is an important aspect of analysis. The general principle of normalisation is the one that we want to emphasise, and the particular example that you will encounter quite a lot, particularly as you look at economic data and business data over time, is this idea of dealing with inflation or the effects of price rises and getting the real story of what's actually going on. If this was a graph, for example, of a business's sales revenue over the last 25 years, it would probably also go up quite dramatically, and it would look like the business is booming. But probably that business has been increasing the price of its services or product over that time as well, because of general inflation. And so whilst it looks like the massive growth in the business, most of that growth is just simply the fact that they charge more for their goods or services now than they did before. So standardising by price increases will give you the orange line, which tells you what's actually going on in terms of real growth in the business. How many more products are we selling? How many actual services have increased in the time? Okay, so very important idea. We calculate index numbers as a means of kind of standardising or normalising in lots of areas. The most common one is the consumer price index, but we have price indexes for a whole lot of other things. We've already used the domestic product GDP one on the previous slide, but we can have an index of house prices to get an idea about how average house prices are going up. We can have a share price index which tells us what's happening to the share market. You might have heard of things like the ASX 200, that's the share price index for the Australian share market, but there's the Nikkei Dow, and there's the Dow Jones and the Hang Seng, and for other countries of the world and so on. These are all indexes which give us an average trend in the increases in prices, and they measure relativities across time, not the actual prices themselves. I'm just going to focus for a little bit on the consumer price index as a commonly used index, and we'll leave that. I'm going to leave this thing here and take you across to Excel and see what we're talking about here. So the consumer price index is the most commonly used index, and it gives us an idea about consumer prices in Australia. So let's see where we might find this data. Well, the most common place we can go for a lot of data is the Australian Bureau of Statistics. So for example, if I go to the, just going to make my screen a little bigger here, abs.gov.au, then we get this kind of front screen here, and we see some interesting things. If you're bored one evening, and then have a browse of abs.gov.au and have a look at some of the data that's there. Here's some information. For example, here's the population of Australia. One new person is added every 1 minute and 15 seconds, 25.2 million people. Consumer price index, that's the rate of inflation that we had in the last quarter, 2018, when I created this video. Gross domestic product grew by 0.3% in the most recent quarter. The average wage for Australians is $1,586 per week. So full-time wage. And then the unemployment rate is 5.1%. So there's some interesting things. Now, I'm interested in average wages, for example. So I'm going to click on that. And when I do that, I get a whole lot of things here, which might look a bit confusing, but I can read a little bit of information about the average wage here. And you notice that they talk about a few complicated things like ordinary time, so it doesn't include overtime, and then they have original and trend. Trend just sort of smooths out some of the irregular ups and downs. They then allow you to actually download the raw data over time. So I've downloaded the average weekly earnings for Australia, this one here. I won't download it again because I've already done it once, and I'll show you that in a tick. I'm also going to, so that's average weekly earnings, but if I do look at that average weekly earnings data, here it is here. The problem I've got is that, let's just look at this one. There's a whole lot of complicated looking things here, but this gives me the information from 1994 right through to the present, 2000, or the most recent data, which was May 2018, of the average weekly earnings of people. And you'll see that, well, once upon a time, people were earning $542, so a lot less than they are now. That's in 1994. And then you can see it increasing. Just look at the last column here. I'll highlight the last column for you. Yep, 600, 700. This is now in 2003. $800 by 2005 or 6. 900, we're up to $1,000 by 2012. And then it hits $1,200 by 2018. Okay, so there's quite an increase. $1,200 at the end, $542. So more than doubled between 1994 and 2018. Okay, so that's what's going on. So you look at that and say, well, that's good news. Australian workers have, had more than a doubling of their income over that period. But we know there's been inflation in that period. So what I've done is go back to the ABS, and I've gone to this consumer price index thing, and I've downloaded the CPI data using this Excel spreadsheet here. And when I do that, I get this complicated looking thing here with the consumer price index for each of the cities of Australia. But the one that's most interesting is the one, because prices are different in different cities, but the one that's most interesting to me is the one that gives me the overall consumer price index, this column here. This averages across all the cities of Australia. So this tells me that in that same time period between 1994 and now, prices have on average gone up from sort of 62, which is the index, up and up and up. They hit about 100 in 2012, and by 2018 we're at 113, so almost doubling. So prices have almost doubled in that time period. So what I need to do is make some adjustment to my wages data to allow for that price increase. Now that's what I've got to do that is combine this column of numbers with the other one, and that's not as easy as it sounds because the dates don't line up exactly. I've got to use some little Excel things, something called VLOOKUP, to make sure I match up the right price data with the right data on wages. That's what I've done in these extra columns. I won't bore you with the details. So from the CPI thing, I get that in November 1994 the CPI was 62.8, 95, 64.7, and so on. Then I've used that formula that you saw in the previous page here, this formula here. I've taken real wages equals nominal wages divided by the consumer price index, and I've constructed real wages. Whoops, get that right. There. By taking this number divided by that number and multiplying by 100, and you'll see quite a different story. Real wages went from $863 up to $1,068. So whilst nominal wages doubled from $500 to $1,200, real wages went from $860 something to $1,060 something. Now I've actually calculated what that means in percentage terms. Over that 24 years or so, nominal wages went up by 123%, more than doubled. So it looks like workers are so much better off now than they were. But actually most of that increase was inflation. And in real terms, in terms of what they can do with that money and what they can actually go and buy from the shop, they've only had a very small increase over the 20-something years of 24%. That's, crude simple terms, about 1% a year, which is a pretty tiny increase. So that highlights for us the importance of making a fair comparison across time, and in particular of dealing with this issue of inflation so that we only compare real variables across time. Otherwise we get quite a different impression of what's happening. Okay, so what we've done in this introductory video is just give you a bit of the why do we bother with data analytics and the importance of data, and given a few clues about what sort of things we're going to end up looking at in other videos. But then in the last part here, the technical part has been to just think a little bit about standardization or normalization of data. And the two particular areas has been standardizing by population size, per person. In the case of countries, that's obvious, but it might also be done, for example, in a company. One company is going to be selling more because it's got more sales reps or more shops, outlets. So standardized by the number of shops or the number of sales reps. And then likewise standardizing when you're comparing across time by the effects of inflation. Okay, I hope you found that interesting and helpful. That's the end of the first video. Enjoy.